Hello everyone and welcome back to this second presentation of jSmart. My name is Nordin Rafi Kadri. I am the author, architect and engineer who has developed jSmart from the scratch. Today we're going to see how jSmart can build a business intelligence strategy by creating an enterprise data warehouse in no time. We're going to see also how jSmart can process real-time data streaming. And finally, we're going to see how to build the same data warehouse, but this time based on real-time data processing. So let's start. In the import of data sources, I have configured some data sources that I will use. Here I'm using a CSV file. As you can see, it is called city.csv file, and I have configured everything related to this file, and I called it city file. In fact, the file at the end is just to make the difference for our presentation, but in real life I don't have even to call it a city. I can use any other name. In the database tabs, I have also configured some tables that I will use. For this presentation, I will use MySQL database, but it can be anything. It's not a requirement. In fact, JSmart can interact with all kind of database, gather the metadata from those databases, and build its own process. With these items, customer DB, address DB, country DB, and city file DB, I have created here in design data mapping a dimension, and this dimension, if I will come to here, I will look at it. It is called dimension location. Okay, I can select it because I want to export this dimension to a PostgreSQL database, to another database. So I will have the transactional system. For example, I will have the transactional system in one database, MySQL database, and the data warehouse in another database. And for my presentation, I use the PostgreSQL. Okay. Okay. Now that I have a dimension, I need to create a fact table. We're gonna build our data warehouse based on Ralph Kimball principles. So for that, what I'm going to do is to select a payment text. In fact, is a flat file, and I will go. This file has a header, and I will call it payment file, or I will call it just fact payment. Okay, so remember this fact payment data source, it will be afterwards. The data source itself is coming from a flat file, and by selecting just the header, jSmart can detect its header and all the names within this header. We can see at this file how it looks like. Just a minute. So here, this is the original, and this is the payment, and as you can see, it is as any flat file. It's a normal flat file which has a header and some data, and jSmart is able to detect all its header. Here everything is imported as a string because it is a text file, but we can choose the real field type. For example, for the payment ID, I will select an integer. For the customer ID, I will select also an integer. Here for the staff ID, I will select an integer. The same thing here. The amount, I will select a double. Okay, payment date, I will select a timestamp, and this is the timestamp format for this file. Okay, so like that I have configured my flat file, and I called it fact payment, and I have to click here to process it. Once I get back here to the export of data models, I will export the dimension, and in the same time I will export the flat payment to the same database. I will use the same database for the export. So for this database, which is a PostgreSQL database, we will see a data warehouse based on a fact table called fact payment, and on a dimension called dimension location. And remember that this dimension location has been built based on four data sources. Here they are. We have the customer DB, the address DB, the country DB, and the city file. Okay, I will have to select it. Okay, yeah. So it is a dimension. Okay, and okay. So dimension is configured, and the fact is configured. I will have to push it just a little bit over here. I will see where it is. Okay, I will open. Okay. So if I will get, sorry. Okay. Now that everything has configured, I will click here in create Java programs. Here I will send everything to this directory and configure everything to run on this Spark master. So I have just to click start here to process and engineer the Java programs. Whoop. As you can see on the left, a folder called My Project has been created. It's the same name of my project here over here, and everything has been done in less than a second. As you can see here, in less than a second, several programs, Java programs has been created. I can take a look at them here. Here the same the same version number as here, and we have our programs. So as you can see, in less than a second, jSmart was able to create numerous Java programs that we're gonna use to load our data, to process our data, and create our data warehouse on a Spark environment. And those data, because we have selected a Postgre database at the end, so those data will be all exported to the Postgre database. So I have just to open here a terminal on the same folder, and then I will call Maven. Okay, as you can see here, the build is a success. So everything has been built correctly, and we have to run that. In order to run that, I can write everything, the Spark, submit, and all the parameters, but JSmart is able to produce a file called submit.sh that we can use to submit the file to Spark. And we can see here, for example, that the Spark master is up. Just a minute. Yeah, the Spark master is up. So yeah, another thing that I'm going to check out is, okay, so this is the Postgre database, oh, just over here, and I'm going to check if I have already some tables. I don't have anything, so I will start processing the data, processing the Java files that jSmart has created. Okay. our JSmart in fact, Spark environment is running the Java files that have been created by jSmart. Okay, everything is running. Yep, it's done. So we can check everything here. We'll see that we have two tables on Postgre, the dimension location and the fact payment. So we can see that we have some data over there. Just I will, okay, from the fact payment. Okay, we have all the payment. That's good. And we're gonna see the dimension. Okay, so we have the country here, we have the city here. All those IDs, we can get rid of them because we don't need them. We need only the first one. It's not a problem. And yeah, we have our dimension, and we can build a larger dimension. It won't be a problem. So as you have seen in just a couple of minutes, jSmart has created the whole set of programs, and we were able to run all those programs on the Spark environment, and we have produced those tables on Postgre, and we can produce them wherever we want. It's not a problem. And which is very interesting. And now what we gonna see is how to process real-time data, because what we have seen right now, the data warehouse that we have seen right now, we can get the data, for example, on let's say on a daily basis, on a weekly basis, on a monthly basis if we want. And it is very interesting, and it is the purpose of a data warehouse. So you can run all your reports based on that data warehouse and get all the data that the data aggregation that you want. We can add other dimension, it's not a problem. But what if you are running a critical business and you need to run everything on a real-time basis, which is very interesting. So we can do that by using the streaming capability with the Spark. So what I'm going to do is, okay, I don't need that. I can leave it here. We have our two tables. I can drop them because I don't need them right now. Okay, so there is no table. Okay, that's perfect. Okay, what I'm going to do right now is to create, based on the same data warehouse, a real-time processing using the streaming of Spark. So what I'm going to do is to get back to here. Okay, here I don't need to see it. Here it's the same thing. Okay, I will go to the import of data sources. Okay, I have used previously a CSV file for our payment. That CSV file may come from everywhere, from a third-party system, from a third-party company, or third-party department in your company. So it's not a problem. So what I'm going to do is to uncheck these file. So which means that I am indicating to jSmart that I don't need to work or to process that file. Instead, what I'm going to do, I'm going to indicate to jSmart that I need to work with real-time data. So what I'm going to do is to click here on the networks. Here I will have to configure the data coming from the network so they can be used within jSmart. For that, we can see here, for example, yep, here. So here I have created a small program, and that small program is not a part of jSmart. In fact, that program I am using it just to simulate any real-time data, like the data coming from the financial markets or any real-time data. So what I'm going to use is to call this program. The name of this program is streaming server. This is the name that I gave to my program, and it is simulating the data. So what I'm going to do, for example, if I want to simulate the financial market, I have to do like that and start, and the server will start. If I want to check that I have real data here, what I can do, for example, is to call netcat. So what I'm going to do is to call netcat at that address with that port and see. Okay, as you can see, we have some simulation of real-time data. It's like the data coming from the financial markets. Here we have date. Here we have date and time every second. Here we have a double value, and then an integer value. Well, it's sort of an open value and the close value and the volume. Yeah, if I want, for example, to simulate the payment file, here we have, as you have seen, here we have a CSV file. But what if I'm getting the data directly from a network, from a host? Here I'm using my own host because I'm working on my laptop, on my laptop. So and it can be any address in the network and any part here. So what if I'm getting the data in real time from somewhere? So for simulating this, I have created the same program, but I will use here PY. Well, in fact, PY means that I will receive a payment, real-time payment. Okay, the server has started. If we'll see the same thing on netcat, we will see another set of data. The first one is an integer, it is the payment ID. The second one is it is a date, the date of the payment. And then we have an integer which is the customer ID, and then the amount of the payment is just a simulation of real-time data, so I can use them in Spark, in jSmart, and I can use them afterwards in Spark. So let's see the things. Okay, so let's get back to jSmart. Here I am going to call it fact real-time payment. Okay, I will get the data from this host, from this address, from that part, the duration, which means at the duration of each streaming, it's 1 second, 1000 millisecond, which is the same thing like saying 1 second. This is the separator. This is the format of the data that I will get, and because we are dealing with the network data, so we have to add at each time a new field. For example, the first one, I will call it payment ID. Okay. The second one, I will call it payment date. This one, I will call it customer ID. and the last one is the amount. Okay, now I have to configure the type of each field. For the payment ID, it is an integer. For the payment date, it is a timestamp. For the customer, it is also an integer. And for the amount, it is a double. Okay, so like that we have indicated to jSmart what kind of data we are going to get from the network. We are going to get a set of data which have this schema, and we have to process it. Okay, let's get back here. Here we have, sorry, here we have the dimension location, which is correct. Here, if I will click, you will see that the fact payment that was existing previously has disappeared because we have deselect the process, which means that we don't want to take it anymore. In fact, we want to proceed with this one, the payment real-time, the fact real-time payment, which are the data coming from the network, the real-time data, and we want to save all those data here within the same database. Okay, so we have like that. Okay, and we have to get back to here. Here, the server, we will let it running because we're going to use the data coming from this server. Okay, this is the previous program, and here we're going to use another version for the new program, and we're going to run it. Okay, it's done. And as you can see, it's really very quick. In less than a second, we have created all the programs, and jSmart was able to engineer and produce all the Java programs that will run on the Spark environment and produce all the real-time data and all the database processing on PostgreSQL. Okay, and these are all the files. We can check something. So what I can do, okay, as you can see, jSmart has created about 700 lines of code, of Java lines of code, in less than a second. Any human can do that, you know, so this is a major difference. And what I'm going to do is to run Maven package. So I will package everything. Okay, and now what I am going to do is run everything and see how they look like on the PostgreSQL. Okay, here in PostgreSQL I don't have anything, so I will run the jSmart programs and see. Okay, as you have seen, jSmart was able to produce almost 700 of Java lines of code in less than a second, and honestly no human can do that. And with that speed you will have the opportunity of trying everything, because you will have plenty of time, because jSmart will develop everything. And here we are running everything on Spark environment. Okay, so like that, the streaming should, okay, just a minute. Yeah, we have seen that jSmart has created two tables, and we can see that, okay, we can see that the fact real-time payment is not a static table, but it is based on streaming, and the count of data is growing each time because it's gathering the data directly from that server, process them on Spark environment, and then send them to Postgre database. And as you can see, the streaming is working, and we have a real-time data warehouse like that. Okay, yeah, and we can see the data if we want. Okay. Okay, as you can see, everything is working properly and perfectly. We can try. Okay, here I wrote a query that we can use, for example, if you have, for example, a reporting system based on the data warehouse, and here you can see, for example, how we can use a simple query to get real-time data from our real-time data warehouse. And we can see that each time at each query the data will change. So we don't have a static data warehouse that will change, for example, every day or every week or every discrete time, but we have a real-time processing running on each second. And I'm using each second because I don't want to burn my laptop. I can go lower than that. I can go in a millisecond if I need to. And here you can see all the data are changing. So our data warehouse is running. Here I'm getting the countries, sorry, and here I'm getting the sum of the amount of the payment. Yeah, and we can check that our table. We can check we can check out that our factory time payment is growing up. Okay. Okay, now it's a 187. Yeah. Yeah. As you can see, each second our table is going up, and you can let it like that for 100 years, and it will continue to work. You have just to scale out your Hadoop infrastructure, and that's it. Okay, so as you have seen in this demo, we have started by building a simple data warehouse based on a fact table and one dimension, and we can extend that to several dimensions according to Ralph Kimball principles. And from that data warehouse, by adding a new layer, a layer of streaming real-time data, we were able to build a real-time data warehouse, which is very interesting if you are running a critical business. So thanks a lot of listening, and have a good day.